Hey guys, today we're going to do notes over similar right triangles, and we're going to use the geometric mean to find parts of those similar right triangles. So before we get started, I want to explain the difference between arithmetic mean and geometric mean. Let's say you have two numbers, like 12 and 48. And we're going to find the arithmetic mean and the geometric mean between those two numbers. Okay, so you've done arithmetic mean. That's just the average between two numbers. So when you find the average between 12 and 48, you're going to add 12 plus 48 and divide it by how many numbers you're adding together, which is 2. And so that gives you 60 divided by 2, which is 30. So we're saying that 30 is the arithmetic mean between 12 and 48. It's the average. So another way to look at it, 12 and 30 are 18 units apart. You can add 12 plus 18 to get 30. You can also add 18 to 30 to get 48. So this is an arithmetic number that you're adding to get from one number to the next. This is exactly in the middle. So geometric mean is used with proportions. And remember, when you set up a proportion, I can't say that word, a proportion, you have one fraction equal to one fraction. You have the first number written here, the second number written here, there's a third number, and there's a fourth number written here. So these two numbers here, we call those the extrema, the beginning and the end. So in this case, it would be our 12 and our 48. That's our beginning and ending numbers. This number here is the means. Is the geometric mean between those two numbers. So let's see what that would be. If we put 12 here, we're going to put x here and x here. We're trying to figure out what the geometric mean is between 12 and 48. So to solve this, anytime you have one fraction equal to one fraction, you can cross multiply. So x times x is x squared. 12 times 48, these two multiply together, is 576. To solve this, we're going to take the square root of both sides. And we get x equals 24. So 24 is the geometric mean between 12 and 48. And if I look at that another way, I can think about what number do I multiply by these numbers to get to the next one. So if I multiply 12 by 2, I get 24, and if I multiply 24 by 2, I'm going to get 48. So 24 is exactly in the middle. So it would be considered the geometric mean. Okay, so we're going to use that with similar right triangles. Let me change my page. Okay, we're going to see how when you have a right triangle, like the one I have drawn here, and we talk about similar right triangles with this right triangle, how you're going to get some similar right triangles in this one right triangle is if you draw an altitude from this main right angle to the hypotenuse. So what I'm going to do is I'm going to draw an altitude. Remember, an altitude has to be perpendicular to the line that you're drawing it to. So it's going to form a right angle with that hypotenuse right there. So in doing that, what you've done is you've created three similar right triangles. And what we're going to talk about is how, let me see if I can change pen colors. These three legs right here, they're going to be the mean, and it's going to relate to this hypotenuse right here. And we're going to see that as we set up these proportions. So let me explain that a little better. All right, let's label this triangle. This is A, B, and C, and I'm going to label this point right here D. Okay, so if you'll notice, let me make sure that looks like a B. This is one big right triangle, A, B, and C. And if you'll notice on this big right triangle, I'm going to label this the short leg. This would be the long leg, and this whole part right here is the hypotenuse. So another similar right triangle within that triangle would be this right triangle right here. So this would be the short leg for that triangle, this would be the long leg, and this would be the hypotenuse. So I could set up another triangle, drawn a little bit smaller because it's a little smaller than the other one. The right angle is at that point D. Remember, this AB right here was the short leg, so BD is the short leg for this triangle, and then it goes to C over here. And remember, BC is the hypotenuse for that one. Okay, and then I'm going to draw another one. Let's see if I can show it. This is another right triangle within that one. So I'm going to redraw it over here. It's also a little bit smaller. It has the right angle at D as well. This would be the short leg for that triangle. This is the long leg, and this is the hypotenuse. So this will be the B, and this will be my A. So you've got triangle ABC. It's going to be similar to triangle BDC, and it's going to be similar to triangle ADB. Okay, so like I said, these three legs that come off of the right triangle, when you draw that, let me see if I can redraw this. We've got so much going on over there. So here's your main big triangle. When we drew the altitude right here, these three legs right here, they're going to form geometric means with this part of the hypotenuse. So if I label, I don't know, I'm going to label this A, this B, this C, this little part here D, and this little part here E. So on our big right triangle, this was A, this was C, and this whole length right here ended up being D plus E for that whole hypotenuse. This was D plus E. Okay, then for the medium triangle, the short leg was E. I'm sorry, the short leg here is B. The hypotenuse for this triangle is the part that's across from the right angle, so it's C. And then this little part right here would be E. And then for the bigger triangle, the short leg would be this little D right here. And then the hypotenuse for it would be this part that's across from the right angle, so that would be your A. And then the other part would be your B. Okay, so then you can set up proportions. Like, for example, if I wanted to solve for A, I could use these two with these two. So we could say A over D plus E equals, in this case, this A corresponds to this D, so D is going to go on top, and then this D plus E corresponds to this A right here, so it's going to go on the bottom. If you notice, we end up with the same letter being cross-multiplied, so that's how it's a geometric mean. We can do that with several of the different proportions here. Okay, so let's actually look at our notes just to kind of see how this is going to work out. Okay, these are our notes. What I've done is I've taken this triangle and I've broken it up into this three similar right triangles that it is. Okay, we're going to focus this time on this particular leg here, which is the altitude. So we're calling this the geometric mean altitude theorem. So in a right triangle, the altitude from the right angle to the hypotenuse divides the hypotenuse into two segments, and the length of the altitude is the geometric mean of the length of these two segments. So I've labeled these with the letters A, B, and C just to kind of show you how this particular leg right here is going to relate to the parts of the hypotenuse of the big right triangle, which I've labeled with the A and the C. So putting those letters A, B, and C into the three similar right triangles that I've drawn. So on the main right triangle, this is A plus C. On the medium right triangle, which is this one right here, CN is our little B, and BN is our little C. And then in our baby triangle, we've got the CN is the B, and we've got A is right here. What I want you to notice is that this is never the same leg. It's never a corresponding leg for these two triangles in the middle. So if you'll notice, I have corresponding sides here that I can use to set up a proportion. I can say, let me erase this right here. I can say B over C using this middle triangle equals the corresponding side of that B is A over B. And then you can cross multiply to solve that. So in this case here, in this picture over here, we've got this as our middle leg. If you'll notice, the B here, the leg that was in the middle, it's the one that's getting cross multiplied. So that's going to be our leg that gets cross multiplied. Okay, so this middle leg is going to get cross multiplied with itself, and then the other two, the 4 and the 9, are going to go into the other two spots. It doesn't matter which goes where. And then you're going to end up doing x times x, which is x squared, equals 4 times 9, which is 36. So you end up getting x equals 6. And that would be your answer for that one. In this problem, again, let me change colors just to do something different. In this problem, the 4 is the leg that comes off of that main right angle. So it's the one that's going to get cross multiplied with itself. And then the other two legs are what's going to go in the other two spots. So then when you cross multiply, 4 times 4 is 16. And then 2 times y is 2y. Solving for y, you're going to divide by 2 and you get 8. So this leg right here is 8. All right, on this triangle over here, this main altitude that's drawn from the main right angle to the hypotenuse, it's the one that's going to get cross multiplied with itself. And then the other two legs, the 4 goes here, or the other two parts of the hypotenuse are what's going to go here and here. So we have 6 times 6, which is 36, equals 4 times x plus 4. And so solving this, I'm going to divide both sides by 4, so this becomes 9 equals x plus 4. Subtract 4 from both sides, and I get that x equals 5. So that tells me x is 5, which means that this whole length here would be 9. All right, let's see another version of this. Okay, now we're going to do another example where this time we're using one of the other two legs on that main right triangle. A while ago we used this leg right here, the altitude. So we're not going to use that this time. We're going to use this leg. And we're going to see how it relates to the parts of the hypotenuse for the main right triangle. So what I've done is I've redrawn the 3 triangles, and we've got the main big right triangle. It's drawn first, where we've got this leg A, and then we've got the hypotenuse, which would be the B and the C added together. And then we've got the medium triangle, which is this one right here. The only part of that triangle we have in this case is the long leg, which is that C right here. And then we've got the baby triangle right here, where we've got its short leg is B, and its hypotenuse, the part across from its right angle, is A right here. Okay, so if we're going to set up a proportion, we would have to use these two triangles. So we would do A over B plus C, and that equals the A. This A corresponds to this B right here, so B over the hypotenuse A. And if you'll notice, that leg A right there, it's what ends up getting cross multiplied by itself. Every time we do this, these 3 legs right here that stem off of that right angle, they're going to be what ends up getting cross multiplied. So we're going to use that on the rest of these examples. Let me switch sides. Okay, so using that, this, by the way, is called a geometric mean leg theorem. So this is where we're using one of these legs off of the main right triangle. So I'm going to label that A. I'm going to label this B and this C. So that A will be what's cross multiplied with itself. And then the part of the triangle, you can even maybe draw a little angle right here to help you see what triangles this A is part of. This A is part of this little triangle, so the B will go right here. And then it's also part of this big triangle right here. So we're using this B plus C part. That's going to go right here. Now let's say we had been given this part right here. So I'm going to label that A, and this is our B, and this is our C. So in this case, if I label this acute angle right here, it goes, again, that one leg is going to get cross multiplied with itself. This A is part of this triangle right here, so C is going to go right here. It's also, it's also part of this bigger triangle right here, so B plus C is going to go here. All right, so let's use that in these examples down below. So this is our main right triangle. This 27 is one of those legs that come off of the main right angle. It's going to be what's cross multiplied with itself. And then it's part of this little triangle right here. So the part of the hypotenuse that it's part of is 16. And then it's also part of, let's see if I can erase that. It's also part of this bigger right triangle right here. And that hypotenuse is this y right here. So y is going to go right here. So again, let me just make sure I show that. The 27 is the main leg. It's what gets cross multiplied with itself. It's part of this medium triangle right here. And it's also part of this bigger right triangle right here, this y. So those get cross multiplied. So then cross multiplying this, we get 16y equals whatever 27 times 27 is. All right, that's 729. And then you're going to divide by 16. And you get a yucky number. You can do either 729 over 16 to keep it exact, or you can say 45.6. All right, let's do another example. Okay, on this next one, this is one of our legs that come off of this main right triangle. So it's going to be what's cross multiplied with itself. And then it's part of this triangle right here. So the 2 is going to go here. And then it's also part of, let's see, it's also part of this bigger right triangle right here. And that whole length is 8 for that hypotenuse, so it's going to go here. So y times y is y squared. 2 times 8 is 16. Take the square root of both sides and you get that y equals 4. So that would be the answer for this one. I'm going to leave this one as 729 over 16. Okay, on this one, next one, this 6 right here is one of the legs that come off of that main right triangle. It's going to be what is cross multiplied with itself. And then you're going to put 5 right here. And you're going to put this whole length right here, because remember, the 6 is part of this right triangle. That's why we use the 5. And then it's also part of this bigger right triangle right here. So this length is this 5 plus y. So 5 plus y will go here. And then you can cross multiply. So 6 times 6 is 36 equals 5 times 5 plus y. And that equals, when you simplify that, 5 times 5 is 25 plus 5y. Subtract 25 from 36 and you get 11 equals 5y. And then divide by 5 and you get 11/5. So this would be 11/5. All right, let's do some more examples. Okay, actually these are kind of an in-class practice, so you may want to do these on your own and then check your answers. I'll be explaining them as I work them, but I just want to make sure that you know it might be a good idea for you to practice on your own. Okay, so this is one of those 3 legs. Remember, we always relate it to one of these 3 legs and how it relates to this hypotenuse right here. Okay, so the one that we have this time is the main, the altitude in the middle. So it's going to cross multiply with itself. And then the parts of the hypotenuse that it's part of this triangle right here, and it's part of this triangle right here. So the 25 and the 4 are going to go here. And so you do x times x, you get x squared. 25 times 4 is 100. Take the square root and you get x equals 10. So that would be my answer for that one. Okay, again, this main altitude right here, it is part of this triangle right here, and it's part of this triangle right here. So that leg that comes off of that main right angle, it's what's going to get cross multiplied with itself. And then you'll put 6 and 6 here. From this 6 and this 6, that's where we got those 2 6s. So cross multiply, you get x squared equals 6 times 6 is 36. Take the square root and you get x equals 6. All right, on this one, again, from this main right angle, we have these 3 legs that stem off of it. They're the ones that will be set up in the geometric mean. So 8 will go here and 8 will go here. The part of the triangle that this 8 is part of is this little triangle here, so the x will go here. And then it's also part of this medium triangle, so the 20 will go here. Cross multiply, you get 20x equals 64. Divide both sides by 20, you get 64 over 20, which is going to simplify to be 16/5. Okay, let me do some more examples. Okay, on this one, this time we have this, remember you're using this main right angle, and these three legs are the ones that will be put in the as the geometric mean. They'll be what's cross multiplied with each other. So this x right here is part of this triangle right here, and it's part of this triangle right here. So when we do our cross multiplying, and we relate it to that hypotenuse, we're going to put the 2 here and the 8 here, because those are the parts of the hypotenuse that go along with those two different x's. So cross multiply, you get x times x is x squared, 2 times 8 is 16. Take the square root of both sides and you get 4 for that x. Okay, again, this 9 is one of the legs, one of the three legs that stems off of that main right triangle, so it's going to be what's cross multiplied with itself. It wasn't a letter this time, it was a number. It doesn't always have to be a letter. Okay, so let's see what triangles that's part of. This 9, is part of this triangle right here. And it's also part of this triangle right here. So the two numbers that will go in the rest of your proportion will be 6 will go here, and then this whole length for the bigger triangle will be 6 plus x. Now cross multiply, 9 times 9 is 81 equals 6 times 6 plus x. That's 81 equals 6 times 6 is 36, we're distributing, plus 6x. I'm going to subtract 36 from 81 and I get 45. Equals 6x, and then I'm going to divide both sides by 6 and I get 7.5, or you could leave it as a fraction either way, but that would be your answer. Okay, on this one, again, off of this main right triangle, these three legs are what gets put in a cross multiply situation, or they'll be the geometric mean. So x will go here and x will go here. The triangles that x is part of, it's part of this triangle right here, and it's part of this triangle right here. So the two numbers that are going to go in the rest of that proportion will be 20 for this triangle, and then this length for the bigger triangle would be 4 plus 20, which is 24. So cross multiply, x times x gives you x squared, and 20 times 24 will be 480. And then you're going to take the square root of that, so that becomes x equals the square root of 480. You're going to want to simplify that. Technically that breaks down into the square root of 16 times the square root of 30, and that would be 4 square root of 30. You could do your number tree as well, but that's an exact answer. Or you could have gotten a decimal as well for that. Okay, let's mix all of this up in the next problem. Okay, on this problem, we have 3 variables to solve for. And remember, this is the big right angle for the big right triangle. So these 3 legs that come off of that big right angle, they're the ones that will get cross multiplied with each other. So you'll have a situation where you have z getting cross multiplied with itself. You'll have a situation where you have y getting cross multiplied with itself. And you'll have a situation where you have that 5 getting cross multiplied with itself. You just have to see which triangles each of those are a part of. I'm going to redraw the 3 triangles. I'm wondering if that might help a little bit. Okay, let's talk about this a little bit. If we wanted to start with y, this y right here, we would use this, and we'd end up having 2 variables in that situation. So that's probably not a good idea. If we were to use z, we would be using this x and then this whole length right here, the 4 plus x. Again, we're going to have two variables in that situation, so probably not a good idea. We're probably going to need to start with this 5 right here. And we're going to see how it relates to this 4 and then with this length right here. So then you'll only have one x in that situation. So I'm going to kind of show that here. What we're going to be using is this 5 right here. Oops, I just erased it. Sorry. Let's see if I can undo that. There we go. And we're going to use this 5 right here. And we're going to relate it with the x. So we're probably going to use, let's see, we're going to be using this right here and this and this. Those are the corresponding sides right there. So setting up my proportion, we're going to do 5 over 4 equals x plus 4 over 5. Cross multiply, we get 25 equals 4 times x plus 4. So you get 25 equals 4x plus 16. If I subtract 16 from 25, I get 9 equals 4x. Divide 9 by 4, and you're going to get 9/4, or you could say 2.25. Either answer is fine. Okay, now we know that x, what its value is. This is 2.25. That should help me a little bit. This is 2.25. All right, now I can use the y. So the y, this right here, gets cross multiplied with itself. It goes with this triangle and it goes with this triangle. So we're going to do this y right here with the 2.25, which was right here. And we're going to relate it with these two right here. So you're going to say y over 2.25 equals 4 over y. And then cross multiply, so I get y squared equals 4 times 2.25. So that gives you y squared equals 9, so y equals 3. All right, now we know this y value is 3. Now we can find z. So this z right here, it's part of this triangle right here. So we're going to use that 2.25. And it's also part of this triangle right here. So we're going to use this whole length right here, which is 4 plus 2.25 or 6.25. So 6.25 is going to go here. So we're going to do z times z, which is z squared equals 2.25 times 6.25. Okay, so you get z squared equals 14.0625. When you multiply that out, take the square root of both sides and you get 3.75. And those are your answers for that one. Okay, thanks y'all.